Now today's topic is the bubble sort, and in bubble sort the strategy will be comparing adjacent elements and exchange them if they are out of order, and comparing the first two elements, the second element and the third elements, and so on. And we will move the largest or the smallest element to the end of the array, and these repetitions will goes eventually the sort array into the ascending or descending order. As we can see in this figure, the first two passes of a bubble sort of an array of 5 integers. Pass means when the first elements goes sorted, or means it goes to its appropriate positions. Here in this figure, in figure A, the pass 1 is shown. In initial array, the first of all 29, 10, 14, 37 and 13 will be an array, and in the initial stage we will compare the first and second element, and then second and third element, and then third and fourth element, and then fourth and fifth element. And after this comparison we pass the first we pass the first phase. First pass means the 37 will gets its appropriate positions, and after this first pass you can see in the figure that the remaining 4 elements are in unordered list, unordered array. 10, 14, 29, 13 are the unordered array, but the 37 is the largest element in this array, and it is on its appropriate position. Now in second pass, the first two elements of an array, means the 10 and 14 will be compared, and then 14 and 29th, and then 29th and 13 will be compared. And in this comparison, if the two elements are not at its positions, then the exchange will be take place. And when analyzing the complexity, in the worst case the complexity will be the big O n square, and in the best case the complexity will remains big O n. Some algorithm work well if the list is already almost sorted. This means the array will be already sorted form, and this will be the best case. But in worst case, each and every element will exchange its position. Now we can see this example. Suppose this is another array: 9, 6, 2, 12, 11, 9, 3 and 7. In bubble sort, the comparison of the numbers in pairs from left to right exchange when necessary. Here 9 and 6 are compared, and there is a requirement of exchange of the informations, exchange of the number positions, means the 6 will gets the positions of 9 and 9 gets the positions of the 6. Here the first element is compared to the second, and as it is larger they are exchanged, and then the second and third elements will be compared. Now the next pair of the number are compared. Again the 9 is the largest, and so this pair is also exchanged. Here the position of 2 will be exchanged with the positions of 9. And now the third and fourth elements will be compared. In the third comparison, the 9 is not larger than the 12. So no exchange will be take place. We move on to compare the next pair without any change to the list. Now the 12 and 11 means the fourth and fifth element will be compared, and as you can see the 12 is greater than 11, and so the exchange will be take place. The 12 is larger than the 11, so they are exchanged. Now you can see the 12 and 9 will be compare. In this comparison the exchange will also take place, and so on. Now the 12 and 3 will also gets exchanged their positions, and after this final comparison the 12 and 7 will exchange their positions, and the last array will be shown as like this. The end of the list has been reached, so this is the end of the first pass. The 12 at the end of the list must be the largest element in the list, and so is now in the correct position. We now start a new pass from left to right. Now after first pass completion, means the last element got its correct position, now the second pass will take place. In this comparison the 6 and 2 will be compared, and in the second comparison 6 and 9 will be compared, and after this the 9 and 11 will be compared, and then 11 and 9 will be compared, and in this comparison the exchange will take place. And after taking the exchange of their positions, the 11 and 3 will also exchange their positions. Now the 11 and 7 will also exchange their positions after comparing. Now notice here that this time we do not have to compare the last two numbers, as we know that 12 is in position. This pass therefore only require 6 comparisons. Now after the second pass, the third pass will take place. Now again the comparison will take place. In third pass, first two elements 2 and 6 will compare, and in this comparison there is no need of exchange of their positions. Now 6 and 9 will compare, and here is also no exchange of positions is required, and after this 9 and 9 will be compared, and after 9 and 3 will be compared. Here the exchange is required because 3 is smaller than 9. Then 9 gets the position of 3 and 3 gets the positions of the 9. And after this the 9 and 7 will be compared, and after this comparison the 7 and 9 will also exchange their positions. This time the 11 and 12 are in their correct position. This pass therefore only requires the 5 comparisons, and after this the fourth pass will take place, because in this pass in the third pass 11th and 9 are at their correct positions. In fourth pass 2 and 6 will be compared, and after this 6 and 9 will be compared, because there is no need of exchanging their informations, and hence the 9 and 3 will be compared, and in this comparison the 3 will get the positions of the 9 and 9 will get the positions of the 3, and after this the 9 and 7 will be compared, and in this comparison also the exchange of their positions will take place. And here each pass requires fewer comparison. This time only the 4 are needed. So this is the, in this case, after fourth case we get the list, and at this time 9, 11 and 12 are at their correct positions. Now in the fifth pass 2 and 6 are compared, as 2 is smaller than the 6, so there is no need of the exchange of their positions, and after first comparison the second comparison will take place, and there is a need of the exchange of their position, and 6 will be replaced by the 3, and after this the 6 will be compared to 7, and the list is now sorted, but the algorithm does not know this until it completes a pass with no exchange. This will be the conditions for the terminations, that when there is no need of the exchange of their exchange of the positions of the elements, then the algorithm gets termination. And in the sixth path we will compare the first two elements 2 and 3, and then 3 and 6, and then as we know 9, 11 and 12 are at their correct position, so there is the need of only up to the 6 and 7. This pass no exchange are made, so the algorithm knows the list is sorted. It can therefore save times by not doing the final pass. With other lists, these checks out save much more work. Now some frequently asked question regarding the bubble sort example: which number is definitely in its correct position at the end of the first pass? Now the answer: the last number must be the largest. How does the number of comparison required change as the pass number increases? Here each pass requires one fewer comparison than the last. How does the algorithm knows when the list is sorted? When a pass with no exchange occurs, this will be the conditions for the terminations of the algorithm. And what is the maximum number of comparison requires for a list of 10 numbers? Answer: 9 comparison, then 8, then 7, 6, 5, 4, 3, 2, 1. So total will be the 45. Okay, thank you. If any queries or questions arises in this topic, then please contact me. Okay, thank you.